Hello everyone. My name is Gahamanyi viateur. Today I'm going to share with you the way we test convergence of series. We have different tests of convergence. The first one we have ratio test. This is one way you can test or you can use to test whether a series is convergent. And the n-through test is also another technique or test that you can use. You can use geometric test, you can use comparison tests, or you can use limit comparison tests. So for our case, let us just use this ratio test to test for our series. Having summation from n, which is equal to 1 up to infinite, of negative 2 to the n times n factorial over n power n. This is our series. And we are going to test its convergence. First of all, you have to have this knowledge when testing. Let us use the ratio test using ratio test. Normally, when you are using a ratio test, first things you have to do, you evaluate limit. You find limit as n tends to infinite of un plus 1 over un in absolute value, and this should be equal to error. And this error, it is the constant that you will get. Normally, when error it is less than 1, you conclude that by saying that the series is just convergent or simply converges. And if error it is equal to greater than, or simply it's just a greater than 1, you conclude that the series diverge. In case error it is equal to 1, for here it is inconclusive. This is inconclusive. And now, for our series, you can see that we are having a series that we are going to use ratio test to test whether it is convergent or divergent. First of all, we need to find un plus 1 by following the formula. So we evaluate limit as n tends to infinite of un plus 1. Taking our series un plus 1, this is un. If you need un plus 1, will be negative 2 power n plus 1. You just replace where there is n, you put there n plus 1. And for here, I'll get n plus 1 factorial over, this is n plus 1 power n plus 1. And over, this is the value for un plus 1. And I'm going to divide with un. Un is, I will copy my series as t negative 2 power n times n factorial over n power n, and in absolute value. This is just what we are going to evaluate. And for here, allow me to frame this. We do frame here. You can see what we have. Of course, you can see now. It means if I have already written this well. So you know that I'm having a fraction divided by a fraction. You know, you take the numerator, then you multiply the inverse of the denominator, which means I'll be having, this is just going to be negative 2 power n plus 1 times n plus 1 factorial over, this is n plus 1 power n plus 1. Then I multiply the inverse of the second, which means this is n power n over negative 2 power n times n factorial. Guys, let me hope that this is clear. And of course, I will need just the absolute value of this one. If you observe carefully, you will find that for here, this is an exponential expression. Just I have to split them by having -2 power n times -2 power 1. You can see that when there is sum for the power, you have to take that -2 power n times -2 power 1. Then I multiply n plus 1 factorial over, for here this is n plus 1 power n times n plus 1 power 1. By reminding, just remembering that when we have the same base, we add their powers. If I take this the same base, when I take the right one, then I add power, I will get back to the previous step. Then I multiply n power n over -2 to the n, then n factorial. If you observe here carefully, you will see that this and this will be simplified. And of course, with my absolute value, so I will remain with the -2, this one, power 1, doesn't make sense to even write one, and you come for n plus 1 factorial. Let's come to this one. When I'm having n plus 1 factorial, this is equivalent to n, let me use just other color. This is equal to n plus 1 times n plus 1, then minus 1 factorial. By remembering that if I'm having 3 factorial, this is equal to 3 times 2 times 1. If you follow this rule, you will get that n plus 1 factorial is equal to n plus 1, then n plus 1 minus 1. You see, -1 and the +1 will be cancelled. I remain with the n plus 1 times n factorial. So I'm going to take this, I plug in there. Is the value for n plus 1 factorial. I will get n plus 1 times n factorial, look, over, it is just over, I copy this one, you see. For here, I'm having n plus 1 power n times n plus 1 power 1, which is still being n plus 1. Then I'm going to multiply with the n power n over n factorial in absolute value. If you observe it carefully, of course, you will find that this n factorial and this one will be simplified. They are simplified. Also, if you observe it carefully, this n plus 1 and this n plus 1 also are going to be simplified. We are remaining with, so I think I can frame here, you see. Up to here, I'm going to remain having -2, this one times n power n, this one over n plus 1 power n in absolute value. If you observe it carefully here, you will find that -2, if to go out of absolute value, I will just get a +2. Absolute, remember that absolute value of -2 gives it +2. That's why this 2 is going to go out of absolute value or magnitude to still have n power n over n plus 1 to the n, like this one. Guys, if you remember here, also there is another rule that of exponents that we have to remember. Remember that let me use this part when I'm having a over b power, you see, a over b, excuse me a little bit, a over b, where a is powered n and b is powered n. This is equivalent to a over b both to the n. Look at this. I think you might be familiar with this theorem or these just rules, basic laws for exponents. That's what I'm going to apply here. Of course, I'm going to get this is equal to 2, this 2 out, and the n over n plus 1 and the power n both. But guys, remember at the time where we started, we were evaluating remit as n tends to infinite of un plus 1 over un. In other words, don't forget the other remit that we had before. I'm going to apply my remit. Now, this must be equal to remit as n tends to infinite of un plus 1 over un. That's what we are going to do. And un plus 1 over un, the result of un plus 1 over un is this one. So I'm going to apply my remit to get remit as n tends to infinite of 2. I can even put this 2 here of n over n plus 1 power n. Guys, if you remember very well, you see here, this 2, I can even take this 2 at the front. Yet, let me put my 2 here. And you see, evaluating the limit of this one, limit if of this rational function, we have just to consider the highest degree, their power, which means this is power 1 and power 1. Then I take their coefficient. The result in bracket will be 1, then power infinite, which is an indeterminate case. When you have got an indeterminate case while evaluating a limit, as a mathematician, you really know that you have to try the techniques of removing indeterminate case. That's why this indeterminate case is removable. We are going just to remove it. There are different techniques of removing indeterminate case. I think you might be familiar with it. Let me, coming back to this fact, I think I can point here. You remember that from the fact of mathematics, when you have a limit as n tends to infinite of 1 plus a over n power b n, and you have a limit of this form, this is equivalent to e power a times b, product of a times b. That is the answer. And you see for here, you can evaluate long division. By long division, we get that n over n plus 1, which is in a bracket, then power n, this is equivalent to 1 plus negative 1 over n plus 1. You see, this is like this one. Then you power it to n. You see, if I put on common denominator, of course you will get back to this. And if you try to compare this to this form, you will find that for our case, A it is equal to -1, and B it is equal to, here there is 1. In other words, limit as n tends to infinite of 1 plus -1 over n plus 1 to the n. This is equivalent to E, like this one, then AB. A times B, this is going to be -1. And remember that at the beginning we had 2 here, which means I have to add my 2 here, and which is going to come to the result. The answer is going just to be 2 over E, which is equivalent to that one. And you can check in your calculator and say, remember that I said this is the value for A. And if error is less than 1, we say this is converged. And if you check in the calculator, you will automatically find that 2 over E is less than 1. What is the conclusion then? The conclusion is that this is convergent. Okay, thank you guys for watching this video. I wish you can subscribe to my channel and follow many updates. I mean, many videos are coming. Thank you very much.